So, good morning. So, in the last class, we have discussed the problems on evaporation, how to compute the evaporation by using the pan evaporation values, and also how to find the evaporation losses by using the Harton's equation as well as Mayer's and Royer's equations. So, this problem we have discussed, and we have calculated evaporation losses for that particular week by using all these methods. Now, so next, I think we have discussed something about the consumptive use of water. Consumptive use of water is nothing but it is the evapotranspiration requirement for a particular crop. So it can be estimated by using a well-known method known as the Blaney-Criddle method, and this method is generally used throughout the world in order to estimate the consumptive use for a particular crop grown in a particular area. So the general equation is of the form, so U is equal to sigma Kp into 4.6 times T plus 81.3 divided by 100. So it is expressed in SI units, metric units. So now here, U is nothing but the use. So now here U is the total consumptive use, that is sigma into K into F. So here F is nothing but it is P into 4.6 times T 81.3 divided by 100. So K is a crop factor. So this value will be given, and this value differs for different types of crops. So next, the equation can be rewritten as K into sigma F, K into sigma F. So K is nothing but the annual or monthly or seasonal consumptive use factor, and F is nothing but whatever the that is percentage of sunshine hours you have to add here. P stands for percentage of sunshine hours, and T stands for the mean and median temperature during that particular growth period of a particular crop. Now we shall work out one numerical problem or discuss one numerical problem. So involving the concept of Blaney-Criddle method. By Blaney-Criddle method, we shall work out a numerical problem. So now here, determine the evapotranspiration and irrigation requirement for wheat crop if the water application efficiency is 65% and the consumptive use coefficient for the growing season is 0.8. Here the value of K is given from the following data. So you have the following data. A particular crop, that is wheat crop, is grown in a particular month, that is from November to February. So wheat crop is a Rabi crop, and this is the mean monthly temperature during that growth period. So that is 18, 15, 13.5 and 14.5, and this is monthly percentage of sunshine hours. So here are the values and the effective rainfall during that period. So it is given in centimeter. Now you have to calculate the consumptive use for this wheat crop, that is the water required by the wheat crop to meet its evapotranspiration process right from November to February. So the crops are sown in the month of November and it is harvested in the month of February. Now, so let us go through the solution part. So here the month, first column. So second column you have the mean monthly temperature in degrees centigrade. It is already given here, and also mean monthly percentage sunshine hours is also given. Now effective rainfall is also given here. So now you calculate sigma P. Sigma P works out to be 10.9 centimeter. Now the monthly consumptive use factor. So you have to calculate the value of F, because the equation is U is equal to sigma Kf, or U is equal to K into sigma F. Now here you have to find out this value F. So this is given by the equation P into 4.6 times T 81.3 divided by 100. So here P is nothing but the percentage of sunshine hours, and T stands for the mean monthly temperature in degrees centigrade. So if you substitute here, you will get the values of F. So you calculate the sigma F value, sigma F. So to submit. So you'll get the value of sigma f. Now it is about 43 point something, 43.54 centimeters. So now you have to calculate the seasonal consumptive use for that particular wheat crop. U is equal to K into sigma f. So the value of K is given, that is the crop factor, that multiplied by the sigma f value. So you get the seasonal consumptive use as 34.83 centimeters. So or 0.34 meters. Now we have to calculate the field irrigation requirement. What is the field irrigation requirement? That is for that particular wheat crop, right from the month of November to the month of February. What is the field irrigation requirement? So that is given by the formula, that is the total consumptive use minus sigma P R. PVR nothing but the rainfall that has occurred, that divided by the water application efficiency. Now in our case, the field irrigation requirement is sigma, so that is capital U is 34.83 minus sigma P is 10.9, that divided by 0.65. So 0.65 is nothing but the water application efficiency. So 0.65 is the water application efficiency. Now if you substitute this equation, so we'll get the field irrigation requirement as 36.9 centimeter or 0.36 liter. So this is the problem which has been solved by using the Blaney Cradle method. So these types of problems you will have in the examination. Now, so next we shall discuss a problem on the infiltration. So now this is a problem on infiltration. So here the time in minutes are given and the precipitation rate in centimeters per hour given. So next is infiltration capacity of that particular soil has been given in centimeters per hour. Now these are the values. Now we have to calculate the rate of infiltration by using the Harton's infiltration curve. So we have already discussed what is Harton's infiltration curve. So now this is the typical Harton's infiltration curve. Now when you plot a graph of infiltration rainfall, intensity of rainfall versus time, and the infiltration rates in centimeters per hour. So you will get two graphs. One is the bar graph. So this bar graph is nothing but the hytograph. So which is a plot of intensity of rainfall versus time in minutes. So on this bar graph, if you superimpose the rate of infiltration, that is the rate of infiltration in centimeters per hour versus time in minutes. So this is the curve, this is the exponential curve. So this curve, initially the rate of infiltration is high, and as the time progresses, it decreases exponentially and it attains a constant value. Now this curve is known as the F curve or the Harton's infiltration curve. Now whatever the area above this curve corresponds to the rainfall, and whatever the area within this shaded area is nothing but the rate of infiltration or the actual infiltration that has taken place, and you can calculate the rate of infiltration at any time interval. So the vertical ordinate will directly give you the rate of infiltration at any given time interval. So now by this graph, you can solve this numerical problem. Now here, these are the recorded time in minutes are given. So, and here you can see 1, 2, 3, 4, 5, 6 after this, every at interval of 2 minutes, the values have been recorded. And these are the precipitation data in centimeters per hour, and this is the infiltration capacity in centimeters per hour. So now with these values, you have to plot this graph. So first one, you have to draw the hytograph, then you have to draw this infiltration curve. Now, so along x-axis, you have the time in minutes, and along y-axis, you have intensity of rainfall as well as infiltration capacity in centimeters per hour. Now, you have to calculate, so you have to choose the scale. 1 square unit is nothing but 1 divided by 60 minutes into 2 minutes. That is, the scale is 1 by 30, 1 by 30 centimeter. So now the rainfall, whatever the rainfall, that is P, that value of P you have to calculate. So in order to calculate this, you have to physically count the number of square unit above this curve and within this line. So how many number of square units you have. So if you plot and if you count it correctly, you may get it around 68.75 square units. Now you have to calculate the area under the F curve. That is the area under the F curve. Now you have to calculate this shaded area. Whatever the shaded area, you have to calculate. That is P minus FP. So you have to calculate this value FP. So now you count the number of square units below this curve and above this line. So you may get it around 26.5 square units. So now you have to calculate the net runoff. So P net or the runoff. So P net or the runoff is nothing but the total rainfall. The total rainfall, that is P minus, that is the FP. So now here under this whole hydrograph, the units are 68.75 and under this curve it is 26.5 square units. So next you can calculate the volume of runoff. What is the volume of runoff about this curve? So it is about 42.25 square units. Now you have to calculate the value of the shaded area also. The shaded area is this area and that works out to be 8.25 square units. So now from the graph you have to extract these values. First what you do is you plot the hydrograph and you calculate the number of square units below this hydrograph. So that is nothing but the total rainfall. Then what you do is you draw this curve and you count the number of square units below this curve and hold this area. So that works out to be, that is the 26.5 square units. Then you find out the square units within this shaded area. So that is called as FC. So FC works out to be 8.25 square units. Now the runoff P net or the runoff is nothing but total rainfall minus FP, that works out to be 42.25 square units. Now we shall apply these values in the Harton's equation and let us check whether the values by Harton's equation and by graphical method are almost similar. Now these are the values that you get. Now you have the Harton's equation to solve the problem. Now the precipitation and infiltration versus time are plotted as shown in figure. In the Harton's equation, the Harton constant value required. That is, Harton's equation is of the form F is equal to Fc plus F naught minus Fc into e to the power of minus kt. So you want this constant k. So this constant k is nothing but F naught minus Fc divided by capital Fc. So in our case, we have calculated from the graph, that is the shaded area below that infiltration curve is 8.25 square unit. So if you multiply it by the scale, so you will get it as 0.275 centimeter. Now we have to calculate this k. We have to calculate this value k. So k is nothing but 4.5 minus 1.2. So this is got by. So you can see here initially F naught value is somewhere here. So it is 4.5 centimeters per hour. And capital FC, so when it attains a constant rate, it is 1.2 centimeters per hour. So now if you substitute 4.5 minus 1.25 centimeters per hour, that divided by the value of k is 0.275 centimeter. So you will get it in 12 hours to the minus 1. So now the Harton's equation, basic equation is F is equal to Fc plus F naught minus Fc e to the power of minus kt. So here if I substitute Fc as 1.2 and F naught as 4.5 and Fc as 1.2 e to the power of minus 12. So k is the value of 12 times t. So F you will get it as 1.2, 3.2 divided by e to the power of minus 12t. So now by Harton's equation, so this is the value of the infiltration. Infiltration F is equal to 1.2 times 3.3 divided by e to the power of 12 times the T. So the value also to be 1.7 centimeters per hour, which is very near to the observed value of 1.8 centimeters per hour. Now here, so now here by Harton's we got it as 1.7 centimeters per hour. Now here the total rainfall works out to be 68.75 square unit, that is 2.29 centimeter, and the excess rainfall works out to be 1.14 centimeters. So now if you integrate it, so this is not included in your syllabus. Anyway, if you integrate these values, so you'll get the net precipitation as 1.41 centimeter, which is almost similar. So this is not included in your syllabus. Only thing is, by using this graph, you can calculate the value of F. So that is 1.7 centimeters per hour. So next, one more problem. So it's a general problem. Always you have this problem in the examination. So to determine the phi index value, and also the W index value. Now here, the rates of rainfall for the successive 30-minute period for a 3-hour storms are given. So these are the rates of rainfall in a period of 3 hours at every 30 minutes. So these are the rainfall values: 1.6, 3.6, 5, 2.8, 2.2, 1.0 centimeters per hour. The corresponding surface runoff is estimated to be about 3.6 centimeters. So now establish the phi index and also determine the W index. Now, so the phi index is nothing but it is a line which divides the total rainfall into the excess rainfall and the net loss, or the infiltration losses. So by constructing the hydrograph, so phi index is nothing but sigma I minus phi into T is equal to P net. So the net rainfall is nothing but it is summation of the intensity of rainfall, whatever the intensity of rainfall, minus the phi index value multiplied by the time period. So that is nothing but the P net, or the net rainfall, or the surface runoff. Now here in our case, so we have the rainfalls, that is 3.6, 5.0, 2.8, 2.2. So now we shall assume the constant rate of infiltration as 1.6 centimeters per hour. So that is the constant rate of infiltration. So above this 1.6 number have to be considered, above this 1 point, because we have assumed the constant rate of infiltration. Now, so if you substitute these values, that is 3.6 is sigma I minus phi. So 3.6 minus 5 plus 5.0 minus 5, 2.8 minus 5 plus 2.2 minus 5, because we have assumed a constant rate of infiltration. So below these values, that is 1.0 is not taken into consideration. Only these values, these 4 values have been taken. Now, so this multiplied by the time period. Time period is 30 divided by 60. 30 divided by 60. So that is equal to the net value, that is P net value, that is 3.6 centimeter. Now, after substituting phi as 1.6 centimeters per hour, because we have assumed a constant rate of infiltration. So on substitution, you will get the value of phi as 1.6 centimeters per hour. Now, if you substitute phi here as 1.6, 5 minus 1.6, 2.8 minus 5, 1.6, 2.2 minus 1.6. So multiplied by 30 by 60 is equal to 3.6. We'll get the value of phi index as 1.6 centimeters per hour. So which is almost equal to the assumed value. It is almost equal to the assumed value. Now, you calculate the total rainfall in that particular time period. So you sum all the intensity of rainfall, that is in centimeters per hour. So that multiplied by the time period. So you get the total rainfall as 8.1 centimeter. So now W index W index is always less than the phi index value because here the losses are taken into consideration. Now here in the total rainfall, it is 8.1 centimeter. So minus Q is nothing but the whatever the rainfall or the surface runoff, total rainfall minus the surface runoff divided by the duration of the storm, that will give you the value of W index as 1.5 centimeters per hour. Now you can see here the W index value is always less than the phi index value because here we don't consider the losses, interception losses and depression storage, whereas in case of W index, we take into account the interception losses as well as the depression losses, and the effective runoff is taken into consideration. So it has been deducted from the total rainfall. So these are some of the problems on infiltration and also the evaporation and how to calculate the consumptive use or the evapotranspiration requirement of a particular crop. So next is 1 minute. And now this is the general blending total equation. So it can be either of this form or the one which I have explained. So both are same. So now this completes the module 2. So next class I will be starting with the next module, module 3, and I will give one assignment. So including both module 1 and module 2. Anyway, I will the study material for module 2 will be shared. So anyway, on tomorrow or day after tomorrow, I will give the assignment, first assignment. So I'll give you some sufficient time for submission. I think your first session is from end of this month. I don't know. I have not received the timetable. So do you have any questions? Hello? Anybody is having any clarification or questions? Hello? Purnima SB? Purnima SB? Purnima SB? Pranita Shetty? Am I audible? Ritu SM?
Yes, sir, audible.
Ritu
Yes,
SM?
sir. Yes, sir.
Purnima? Purnima SB? Purnima SB, are you there? You had some problem with attendance. Okay, so there is no, and I request all of you to mark your attendance in the chat box. So I'll be ending the session. So we shall meet on Monday. So till then, take care. Have a nice day. Thank you.